Welcome to the last day of notes in section 6.2. We're going to do integration with our trig functions. So for these, the first part is remembering your 6 trig functions and their corresponding derivatives, because now we have to work backwards from the derivatives to figure out who is the original function. The first one is finding the antiderivative of cosine of x. The way to approach it is to think, who has a derivative that gets me cosine? So you think back, whose derivative was cosine, and it was sine. So my antiderivative is sine of x, and then plus c, just like before, because it's an indefinite integral. My next one is secant squared. So I'm thinking, who gives me a derivative of secant squared? That's how I'm going to figure out the antiderivative. So in your brain, I hope you're remembering whose derivative is secant squared. That is tangent of x. So then I put plus c. To help you with doing all this trig stuff, what I would recommend is somewhere on your paper or on a separate sheet of paper, take and write out 2 columns. One with the 6 trig functions and the other with their corresponding derivatives, like I did right here. So here's our 6 trig functions, and then here are all their derivatives. So that way you're working with something you're comfortable with. And then when I have to work backwards, like this, to do the antiderivative, I just have my list in front of me, so then I just have to work backwards and see who's on that list. So for number 3, in my example case, I would look on that list, and negative cosecant cotangent is on that list, and that one is the derivative for the cosecant of x. So that's how I work backwards. When I'm looking on my list, cosecant squared is on the list, but it has a negative in front, because all your c trig functions, when you see a c, you go under the c, and they go negative. So this one doesn't have its negative. When you compensate working backwards, you would say negative cotangent of x plus c. That way, when I do the derivative of cotangent, it is negative times that negative would get me the positive cosecant squared. So be on the lookout for those negative signs if they're missing. Now we're going to incorporate it with other functions and coefficients. So right here I have 2 cosecant squared. I have a coefficient of 2. Coefficients get carried along. It's the constant multiplier effect. Again, I'm missing the negative, so I'm going to say negative 2 cotangent x plus 7e to the x. Memory recall from before is 7e to the x. And now I'm thinking, who has a derivative of cosine? And that would be sine. The minus 9 is considered the constant multiplier in the front. Since sine goes directly to cosine, I'm just going to keep the minus 9 sine x, because then when I do minus 9 times sine's derivative, it goes just to cosine. They get multiplied together, plus c. So the trickiest part is going to be when you have to use your algebra and trig skills to make a match to some of the derivatives on your list. So in this case right here, I have trig functions, but this combination is not on my list of trig derivatives. Step 1 is to do a rewrite to try to get it to match somehow some derivatives on my list. So I'm going to split it using techniques from our past, the split apart technique. Make it sine x over cosine x. So I've used up my one and only sine with one of the cosines. So what's left is a 1 on top, and then the other cosine here. So I'm splitting it apart. Now if you notice, your trig derivatives are either one trig function or two trig functions multiplied together. So I'm strategically splitting it into a product of 2 because I notice 3 out of 6 trig functions, 4 out of 6 technically, are 2 trig functions being multiplied together. 2 of them happen to be the same thing. Okay? So sine over cosine becomes, memory recall, tangent of x times 1 over cosine is secant of x dx. Now I looked at my list. Tangent times secant is a derivative of somebody. That's the derivative of the secant. So I'm going to say secant x plus c. And that's the end of that one. Now, my next example, dy over cosecant. Well, none of my derivatives are written as fractions. So what I'm going to use is my trig skills to rewrite that. I'm going to lift it up. dy divided by cosecant is the same as its reciprocal trig function, which is sine y times dy. So now I look on the list, and on my list I see a negative sine y, so it's missing its negative sign. So its antiderivative is negative cosine y plus c. And that's its answer. Number 4, I see secant b being multiplied by a group. Now, since I'm either looking for one trig function or 2, I'm going to do that distribution so I can get 2 trig functions together. And then I can look at my list. Secant b times tangent b is the first distribution. And by now I'm hoping everybody's saying, oh, that's on my list, that's familiar. Plus the next distribution is secant b times cosine of b. All of that is in parentheses with db. Sorry, I'm running out of room. This is not on my list. So I'm thinking, not on my list, what am I going to do about that? I'm going to keep the secant b, tan b, because I'm good there. I know it's antiderivative. And then I got to think about the secant being multiplied by the cosine. Secant times cosine. Well, what is secant? Secant is 1 over cosine. 1 over cosine times cosine. Aha! That gets me a 1. So that one just simplified to a 1. Now I'm good to go to anti-differentiate. The secant times the tangent. When I anti-derive, that one didn't come out very well. That one goes to secant of b plus the antiderivative of a 1. It's kind of like going backwards from the linear function x, but in this case it's a b because I'm integrating with respect to b. And then I plus c at the end for my constant. Okay, next page. Almost there. I have cosine over sine. Again, not on my list. So I'm going to say, all right, I want one trig function or 2. Since it's squared in the denominator, let's try separating it to see if I can get 2 trig functions. So I'm going to do cosine of x over sine of x, 1 over sine of x. Now when I look at that, cosine over sine is cotangent of x, 1 over sine, cosecant of x, and then dx. Now I'm looking at my list with my derivatives, and is that on there? Those 2 trig functions are on there. They're being multiplied together. It's missing its negative sign, so I'm going to put in the negative sign. and it's negative cosecant of x, working backwards, plus c. My last example, I have cosecant outside of a parenthesis being multiplied. So I'm going to go ahead and I'm going to distribute it through. So I'm going to have cosecant x times sine x minus cosecant times itself would make it cosecant squared. And then I look to see who is on the list of derivatives. Cosecant times sine is not on my list. So then I ask myself, cosecant times sine. Cosecant, that's 1 over sine. 1 over sine times sine becomes a 1. So I have 1 minus cosecant squared. Is that on my list? It is. So I'm going to keep it right there. And now I'm ready to integrate. The antiderivative of 1 goes to x. Now here's that cosecant squared on my list. It's got its negative in the front. It's good to go. So I can say plus cotangent of x plus c. Now as you go through to do the homework, some of the homework problems are going to be an exact match, because when you're working with 6 trig functions, there's only so many different ways we can rearrange the 6 trig functions. So please make sure to really try and do the homework problems without looking at your notes, so that you can get very comfortable with the 6 trig functions and then how to work with the anti-differentiation. Thanks and have a good night.